In this video, we're going to show you how to program the Galt Pure Power 3 Static Var Generator, or SVG, and the Galt Pure Power 3 Active Harmonic Filter, or AHF. In this particular installation, the customer had low power factor and thus was getting power factor penalties from the utility. In addition to that, he had harmonic distortion, which was polluting the quality of his power system. So we addressed this by putting in both units. The Static Var Generator is a less expensive way to add kilovars to the system, so we put that in to generate most of the kilovars to correct his power factor. The Active Harmonic Filter can also generate kVars, but in addition to that, it can improve power quality by correcting the harmonics and creating a better power quality for the power distribution system. So whenever these units are energized, all you need to do is touch the screen, and the screens then will light up and you will be able to begin programming. So this is the Static Var Generator that we're going to begin programming first. The screen went off. All we need to do is touch the screen and it'll come back on. And you can see we have our grid current and our load current. So that's the uncorrected for the load and the corrected for the grid. Now if we want to change the settings, we click Settings and we need a password. The default password is 080808. And we hit OK and then push Login, and that brings us into the settings. So we will press System Parameters, and these are the parameters we set up to set up the system. The operation mode is the first one we want to look at. There are several operation modes. We can do reactive only. We can do reactive, which is Q, then with what's left over we can do balancing, B, or we could do B balancing first and then reactive. There are a number of selections that you can use there. The second one would be our power on mode. Now we have it in manual right now, and typically we like it in manual, but if we want to change that so it automatically comes on, we can change that. We generally select it manual so we have control over it. The next thing we want to look at is the CT location. That of course is the current transformer. If the current transformers are located on the supply side of the SPD, we select supply. In other words, they're upstream of where the SVG is connected. If the CTs are downstream of where the SVG is connected, then we select load. Next, we select the total capacity. Now, in this case, this particular system is a 90 kilovar system, but suppose that we have 3 of them. Well, then our total capacity would be 3 times 90, or 270. So we would type in 270 here and then select OK, and this unit would know that it's only correcting 1/3 of the total VARs that are required. So in this case, we just have the 1 unit, so we're going to go ahead and program it for 90, which is the capacity of this particular unit. Next, we hit page down, and we will get to the next set of parameters. The compensation mode, we highly recommend that you use intelligent mode. Intelligent mode looks for system resonances and gradually will introduce the kVAR as it checks how the system is responding to that. The only time you would not want to use intelligent is where you had a very, very quick system like a welder or something, in which case you might have to go to sequential. Next is your CT ratio. So we simply enter our CT ratio. In this particular case, we're using a 1200:5 CT, and so we'll enter that and push enter. So if we press page down once again, now we get to our next set of parameters, and in this case we want to set our target power factor. So in this case, let's say we want 0.95. We can go ahead and set that. The PT ratio will be 1 if on a 480 volt system, or 208 where you don't have external PTs. And then we go back to the main screen, and again we can see the unit beginning to take effect, and you can see your load current, which is very nice. See what the actual current is and the power factor in your line current. Notice how much lower the current is with the improved power factor. From the main screen, if you want to turn the unit on, press power on. If you want to turn it off, press power off. Now we're back on the main screen. We want to go back to settings. We have to enter our password. Since it's already in there, we'll just push log in. And now we'll monitor parameters. Now if you have an external display, this is where you would enter your baud rate, your address, and you have a choice of several languages. If you'd like to set the time, all you have to do is push the time button. The next thing we're going to look at is data. If we push data, we can see that we have a number of selections. We have voltage, we have current, we can look at our power analysis, as well as I/O and temperature, and we can do debugging and look at the version number. Let's take a look at voltage. Now this is the grid voltage. That is the voltage that the utility sees after correction. And you can see the waveform of the voltage here, and you can select which phase of voltage you would like to see. From the data screen, the next thing we want to look at is current. You'll notice we can see the grid current, that's what the utility sees, the load current or the reactive current. So here's what the utility sees, and you can see we have our current on all three phases, our power factor, and also our distortion. Clicking waveform allows us to see the waveforms, and you'll notice that we can see both the grid waveform, what the utility sees, and the load waveform on the same screen. And by selecting L1, L2, or L3, we're allowed to see what each of those phases looks like. Now let's go back, and the next thing let's take a look at is the compensation current. This tells you what the actual kVAR compensation is coming out of the SVG, and you can see the currents there and also the waveforms on all three phases. Next we'll go to power analysis, and you can see we have our grid and load all on the same screen. We have our kVA, we have our kilowatts, we have our kilovars, and of course cosine phi is our power factor. So that pretty much completes the data section. From the main screen again, we will press record, and you can see we have alarm and operations records. Let's take a look at alarm first. We have the last 100 active alarms, and we have no active alarms, so let's go to history, and there we'll see the last 100 alarms in our history log. You can see that we've been playing with this unit, and we have lots of alarms in there to take a look at. So let's go to operations, and you can see that the unit has stored the last 100 actions, and each one is date and time stamped. So this is a brief overview of programming the static var generator, or SVG. It is one particular installation and won't necessarily apply to all scenarios. If you have further questions, please check your manual or call your electrical distributor.